Hello everyone and welcome to another video. In this one we will be doing something quite hard, I think, or at least harder than what we've been doing until now, because we'll start working on the server. So, my intention with this video, or the next few videos, is to transfer the terrain generation to the server and basically allow the client to receive the planet data on connection in a relatively fast way, right? Without adding too much complexity. For now, I can then optimize it if it's necessary, but for now, I don't want to add too much complexity. So, um, what I basically want to do, I think, is that we can start probably adding, so I can probably have, let me think. So this math stage, yeah, so I'm thinking about if I want to have, but this is not really base, is it? It's more like a, well, I can put it in base. But in base I can have a planet dot age, maybe, and then I can just have the standard parts that we usually always add. And in here, I'm trying to figure out the best way we can do this. But I think that the best way is to just, where is my app init? Right, so we have this init terrain. So, and this init terrain uses all of this stuff, right? Well, I don't actually need this to be common, or do I? No, not at all. I can just move that into the client itself, right? I can just grab all of these, yoink it, and paste it in my server. But then I need another folder. So we can create a folder for server, right? And this server, I can have it like server.c probably. And here we can start adding all of the stuff we need. So this is going to be that. And I'm probably going to also need a server.age, right? So we can do that. Let's see. Actually, this is fine. What am I doing? Okay. So for now, my server header file is probably only going to contain the app definition, right? And this app definition needs to contain the actual map, right? So this needs to be abstracted away, all of these layers, but I'm going to keep like this for now to simplify things. So I only need this stuff, right? So I can have, if, what do I want? Oh, includes. And I can include standard int, right? And here, this actually needs to be shared. So I can have a config.age, then I can extract that into a shared file. So if I go to my app, then I can just copy all of that and put it in here, right? So this is my config, and then I just need to include the config. I can call it, yeah, config. Yeah, so this should already have here I can follow the same standard, so I can call this app, I guess. So this becomes my app, and this becomes my app. So this is the app. Cool. And here I need to include that base config, right? So now I have access to config, and I also need the definition of solid. That's also very important. So solid is going to be shared by the client and the server, which is good. So we don't need to cast anything or do anything special. So now here we can include the app.page, right? And we need that to be defined as a global variable. So we are going to have a global state. And here I probably can export it so other folders can use it if required. Like this. Right, so I don't want to use this right now. So here I can call this init solids. Well, yeah, init terrain or generates terrain. No, let's keep it as init terrain for now. So here I initialize the terrain and probably want to have a similar structure to the one I have here. Probably want to have an app init and an app close as well, right? And probably have both of them like so. But then I need, well, let's first convert this and then I can think about the network stuff. So app init, and this for now is just going to initialize the terrain, right? And then I'm going to have a app close that currently does not contain anything. Okay. So now inside my server, I will need all of that, to be honest. So here I'll need this, right? I need to copy that. Can probably yank it and put it there. So this is my loop. It's going to be stored directly in the app. I can probably just copy that, maybe. And here, so this is init close, and here I can add something like a app run, possibly. So yeah, I think that's a good approach. So see, this is my run function, and inside the run function I'm just going to have some of this code like this, right? Yeah, probably. So probably I'll also want my app run function to return an integer. Well, but in that case, yeah, because this is an infinite loop, right? So it's not supposed to close ever, unless we receive a signal, a kill signal. So, let me think. Let me keep it as void for now. And I probably don't need close ever. Or I can have close like internal, to be internal, right? So here we want to use app loop. Then this is the initialization, so it needs to be called inside app init. All of this stuff. Yeah, basically all of this. So we can initialize the terrain, and then we can initialize that. And I think that's more or less it. So this is a server. Oh, here we bind it, okay. And yeah, So I probably also want to have this inside app, but I'll see about that. So after that, yeah, so I probably can return an integer, I guess. And this is basically just going to return either exit success or exit failure, right? Basically. And this is going to use app loop. Cool. So now, oh, and I also need all of those things. So this is already imported, but this needs to be included as well in my app.c file. Let me close all of these things that I no longer need. Okay. This also needs to be included. Okay, because of malloc and stuff like that. So now inside my CMD, I can just include um, base. No, I can just include app server app.age, and then I can do app init, right? And then I can probably just do app run like this, and this should be more than enough. Here I need to actually change the signature of this to return an integer. Okay, so this is probably everything we need, right? This is, yeah, this is just being slow. Okay. Right, so this should still work, more or less. I don't know if I need to extract this TCP server into a different variable, but let's see. So now if I do build development server, right, and I change this to server, what is this going to do? Oh, this should actually complain because, yeah. Okay, so this is complaining because, yeah, that's a, why, but I don't use it anywhere. Do I import relive anywhere? No, I don't think so. Because this solid does not import, oh, it imports relive for some reason. I don't need relive here at all. Yeah, I don't need relive there. Cool, so that's that. So here, we try again. Okay, so yeah, so this complaint because this is not defined because we need to change the build script. So we only support development for now, but we later we will support release and development in the future. Development build is going to support auto reloading, right? But only in the future. We don't want to waste time with that now. So here we can do a similar thing we did with the clients. I can probably just append everything that is a C file inside server folder. Let's try that. I think it's already, okay, no. Oh, because yeah, I need to recompile. Let me do gcc cmd builds minus o builds. Yeah, this should be enough. Okay, so now if I do that again, this is probably already executing something. Oh no, it just takes a very long time to compile. That's very strange. So true is undeclared because we need to include standard bool. So this is standard boolean. Okay, so what else is it complaining about? Okay, let's just give it a little bit more time. Okay. So yeah, so that's something I need to fix. So because this currently uses, oh boy. So what is the get random rgn? Is it something a Windows something? This is part, yeah, this part of Windows. Cool. So I probably need fast random number generator algorithm, and also need an algorithm that is good. Let me take a look at the Relive implementation of this. Maybe I can get inspired by it. Cool. So this is just uses the default C function. Okay. So for now, I'm just going to say int get random value min and int max, and we are just going to do the same thing, right? This doesn't do. Oh, this. Okay, so okay, it checks, but this is just for noobs, right? We don't actually need that because we know what we are doing. So rand is part of what lib in C, standard lib. Okay, so we already have that. Then we have this ABS is part of something. Okay, but that's for doubles. Okay, but okay, integers. Yeah, I think we can do that. So, and we don't need the parentheses. So basically what we are doing here is that we get the absolute value between, basically the distance between one point and the other. We add one, we add a minimum. So this one is probably to cover the range. So because we want to include both min and max, then we add minimum to that distance. So we can do modulo. Yeah, because modulo is going to return between that and the other thing. Okay, that's probably going to work. I don't think I made a mistake. Yeah, because this is as priority. So this is going to return me between 0 and the distance between max and min, and then if I have minimum, this is going to return between min and max. Okay, it's correct, I think. Cool. So here we can just use that instead, right? We can just use that. And since we are at it, we actually need to include base math, and this can go to math because other algorithms actually use this random function, for example here. So we can actually just place it below clamp, I guess, and this can go here. So now this no longer depends on Raylib, which is good, which is very good. You can just do that, right? And this is supposed to work the same way. And now, where do I? Oh yeah, it's inside here. So I need to copy this, right? Because I want a math implementation now in my server. So we can add it here. So this as a math implementation. We just defined the implementation once, right? I don't know why I'm making this base module like only single header libs, but whatever. It works, so we cannot complain. And here we have another get random. Okay, so we can say get random value and get random value. And I think we don't use it anywhere else, to be honest. So let's try to recompile it. OnConnect is undefined. Why is it undefined? No, it's defined here. Oh, because I defined it before. Okay. So yeah, let me move it upwards, and I can declare it before having it, right? And so Is this running or not? Okay, let me try to do this. I don't know why this takes such a long time because yeah, my laptop is just dying by the minute. So um, line 84. Oh yeah. So what do I want to do here? To be honest, this can be void, right? So let's simplify our server. This can be void, and here we just crash, right? We just crash, easy. And then we just up init, and it's never supposed to end, to be honest. So we can just do void here, and boom, it's everything is fine now. So let's just simplify our lives, to be honest. There's no need to shoot ourselves in the foot. We just exit, and that's it. So here we return, that's correct. Okay, I don't think we need anything else. Let's see. But I may like integrate with CL compiler because GCC is getting slower. I don't know. Oh, it forces me to be integer. Okay, okay, I can put it as an integer, whatever. So let me just bring back what we had previously, and here I can just say return exit success, right? And for that, I need standard lib. Okay, are you happy now? Let's see. I'm going to suppose this is working. Okay, so this wants to access public and private. Yeah, I'm going to allow it. It's taking some time to allow it. Okay, but I suppose this is now working, right? So now I can close this. And here in my app.c, I can probably also have an info log, right? And I can say listening on ports. And I can just print the port. What's the port I'm using? Let's extract this into the config. I can say define port, right? And whatever port, just a random number, doesn't really matter. So then, and that, okay. And I can say I'm listening on this port. Okay, so now the server is generating a planet. First is compiling, that is taking a very long time to compile. Okay, now it's listening on port 3245. Okay. Let me also add a log here. I can say initializing terrain, right? And then I can then say initializing network or something. Well, it's not really network, it's more like a, I can say TCP server. Yeah. So now we probably should have a better idea of what's happening. Yeah, this is just taking a very long time to compile for some reason. I don't know why. But yeah, the rest is very fast, as you can see. Okay, cool. Now, now comes the hard part, right? This was the easy part because now we need to handle. First, I can probably add the network capabilities to my client, I would say. So this no longer is, oh, this is a server. Let me close all of that so I don't confuse myself. Okay, so this is the server, this is the client. I should probably change these names from app to client and server, but I do that offline. So that's the server and this is the client. App init no longer initializes that, right? What else? What else? Then the rest is the same. I would say probably. Yeah, I think the rest is the same. So now what I probably want, but this is using Libuv, right? And it's, I need to basically create another module, say network or something. And here I need to say the same thing. So if not defined, network page, I can define network page and then end if. And here I need to have an opaque pointer or something like that. So I can say type that struct clients to clients, right? Can do something like that. Even I can actually say something like, well, yeah, I can just call it client, doesn't matter. And then I can have some functions for the client, right? But I need to check that in Libuv documentation. So here I can have a network, let's see, and this is going to include network page. And here I need to actually define a struct called clients. And now I can actually include libuv without having namespace collisions, name collisions actually. So this is uv.age, right? And here, I don't know, I probably need a uv tcp t or something like that, and this is a client. I would assume that this is what it needs. Why is it? Oh, I probably need that there. What? Yeah, so this is how you define. Okay, it's just IntelliSense being super slow. Okay, so now let me have the example. So with uv tcp echo example. I know that we looked at, yeah, it was this one. In the previous, when we worked with the server, right, we used this example. Yeah, so this is a client. Let's see. So the client, yeah, the client also needs a event loop. So let's use it, I guess. There's really nothing we can do about it. So this is also going to need an event loop. This can be, yeah, this can be by value. Does it, yeah, because uv default loop returns a pointer, so yeah. I can say, I can have a function called make client, and this is just going to return me a client. Yeah, why not? So this is the result, and then it's just going to make me a client. So I can probably expose this function. Oh, but this needs to be a pointer, right? Because this is an opaque thing. So call it new client in that case, and this is going to return a pointer. So this is the result. I'm going to include standard lib, right? And here I need to malloc, malloc, and this is size of the results. right? And now I need to initialize all of this stuff. So the loop is going to be UV default loop, and then I need to initialize all of that. So that's the socket. We can call it socket. Yeah, so this is the socket. We don't need to allocate anything. We can actually copy this from our server code because here is the same thing, right? We just initialize it in the same way. So we can do that. And we are, yes, we are going to crash the client if the server, if the socket initialization fails. I don't care. We can, if that's a problem, we can handle that in another way in the future, but for now, that's probably just going to be fine, right? We say results dot socket. So this is going to initialize the socket. So could not init TCP socket, right? That's going to be the same. What else? So they initialize here, then they need this connection. Well, probably, yeah, but this needs to live forever, right? Yeah. So because if this goes out of scope, then yeah, because the connection is asynchronous, right? It's not synchronous. So yeah, we probably need to malloc this. And this is where allocators come into play, because this is easier to manage with allocators, but I'll basically convert this arena allocator from C23 to C99, and then we will start using it for this, because yeah, network code with Libuv really does need allocators, otherwise it's going to be a pain to manage memory. So here we are just going to do the same thing we did in the server, right? So here I can just initialize that the same way, right? IP address, that's fine. Here we need to include base config, right? And it's going to have the ports. Right, so here I can also probably assert result, and I can also probably assert this connector request, right? And I can include assert. Now I need to send the actual request for the connection, right? I can do that. Is this so this is synchronous? Is it? I thought it was asynchronous, this connection request. Let's try to not allocate anything for the connect. Like, let's assume this is synchronous, so we don't, this will survive, this scope will survive for time, for enough time, so we don't actually need it. Let's assume it. Well, but then this onConnect function receives receives that the request, and the request needs to exist. So yeah, we need to allocate it in the heap. Okay. So we actually need that. So here we just print the address, and then we need onConnect function. We can have it. So this is going to accept the request and the status. This is probably the same as the server, I would say. So let's see. Yeah. So then that's the server. This is the, what is, oh, it receives a connect. So these are two different callbacks, right? So because here we use TCP connects, right? And in the server we use, where is this called? Listen. Okay, so they are two different functions, so they have a different signature. That makes sense. Okay, so here, well, this is going to make my life harder. But this is my connect request. This connect request. Oh, but in here I don't need the loop, do I? I don't think so, to be honest. So we are just going to check the status. Yeah, could not connect, and then we don't need any of that. Right, we don't need this because it's just going to send stuff. Oh, this already has a handle, which is nice. But we don't need any of that. We can just say connected, right? Client connected. And here we actually need to do, and this function is actually asynchronous, right? Because we need to do a read start. And this is basically going to queue this command or this event. And this is going to do the stuff we need. But what's the stream? So the stream is the request dot void. Oh, this is a connect request, but oh, they call it request here. Yeah, I can call it request. So this is request dot handle, and this is a stream we need to use, right? So we're going to queue. Oh, this is an allocator function. We can have that function for now. And what's the signature? Okay, I can copy the signature from the header file itself. Oh, this is taking so much time. Right, but this is that. And this is where we would like to have a pull allocator. Right. So we can call it alloc buffer. And so this accepts an handle, and the handle could probably, well, we could just have a global allocator or something, but let's see. So we don't care about the handle for now. Then I basically just need to do buff base is equal to malloc suggested size, right? As simple as that. And then buff length is equal to the suggested size, right? And that's it. We can assert that it was properly allocated, like so. Okay, but I don't think I'm going to use this now. Right, so I'm just going to do this, comment this, and I'm going to leave this for the next video. So we are going to read the map on the next video because this is getting already pretty long. So in this episode, we are just going to establish the basics of client and server, like that. So now my client needs it is new clients, and it returns a pointer. And here I will need to have besides a camera and actors and all of that stuff, I will need a client, right? And here I can include network like this. So I can have a client, and this is a pointer to clients, right? And now inside app init, I can just say, did I? No, it's correct. I can just say that app client is equal to new clients, right? And this should initialize the clients. properly. So I don't know why that's complaining when this is properly whatever. Uh, why? What do you mean? Cannot overload function. What? So this should work. Whatever, let's compile and see what the compiler says. Yeah, it's no longer complaining, whatever. So here we can probably also have a free client, and this is going to accept the clients, right? Accept that. And here we need to implement this, and I think we only, oh, we malloc the connection. Oh, we cannot forget that here this needs to free the request. We must not forget that, right? This needs to free the request, and the same thing here, right? Very important. That's why I want to use allocator, because the chance of me leaking memory is very high when, like, I don't like Libuv for that. But Libuv is an excellent library, just you need to be very careful with allocations. But here we can just free the client, right? And do I need to do anything else? Maybe I need to close the loop or something. Can I do like UV close or loop close? Yeah, I can. What does delete do? Oh, this is deprecated. Oh, there is a fork for the loop. Nice. There is a new. Yeah, I can probably just close it, I assume. So I can just say client dot loop, and this is going to close the loop. Cool. So now inside my app.c, I create a new client, and in app close, I need to also handle the free. So I free that, but I also can free clients, and I can pass app.client. Right. That's probably enough. Okay, so this console is going to be the server, and this is going to be the client. Can probably have something like this, making it a bit shorter so it fits on the screen. Okay, so this is building the client already. Let's try to build it. And because of that, I probably, well, there is an error. Line 56. Oh, what? Oh, because here we need the result sockets. Right? Yeah. Oh, and this needs to be a pointer. Okay. Let's try to recompile that. It seems to be the, okay, no. Yeah, the compilation is getting quite slow. I really need to do something about this laptop. Maybe format it or something, but this expects, oh, this expects the client, so you can return the results, and that's it. Nothing else needed. Just, yeah, I can increase this a little bit. Okay, what about now? Okay, so the client initialized. It's very suspicious that we were not able. So this initialize relief. We didn't get any info about that. Why is that? Oh, because we don't have any print logs, right? So let me have something like a print f here, and I can say info a new client, right? So we can keep track of what's happening. Then this is not doing anything for some reason. What am I doing? I don't want that. Okay. Maybe I need to include standard IO. Let's see. Let's see. Yeah, we basically we are creating a new client. That's doing something, but we never. Oh, because yeah, we don't have the server running. But that's very strange because this I don't know why this never UVTCP connects doesn't do anything, but okay, let's then try to run the server. And I probably will need two threads, right? One network thread and one main thread, probably. But let's see. Okay, so the server is running. And then if I execute my clients, what is this going to generate? So we created a new client, but it never... I'm suspecting that this example is wrong. I think that this is wrong because it never runs the event loop, and I think we need to run the event loop, to be honest. Yeah, I think this is not correct. So, I think so. I think so. So let's try. Let's try then to have another function, something like void. This can be client free, and this can be client no, and this can be client run, right? Or launch. So this is, well, this is not, I probably want this to have like be decoupled. I'm starting to get to this realization. So I don't see much value in having this kind of stuff, right? So what I'm thinking about is that I probably want to have like network init, then network close and network launch, right? Something like this. So these are two separate threads. So this is going to basically launch a new thread, right? Yeah, probably want to go in that direction, to be honest. I don't want to do that because, yeah, it doesn't really add anything of value to have that being shared like that. Okay, so in my now this is going to be the client, and I'm just going to have a global client, right? Because I only need a single client for my client, right? So this is my client. Okay, I can zero initialize it just to be safe. Yeah, now this is not type def, so I can do type def that like so. And this is no longer new client, this is now network init, and this is network close. And here we just use client.loop, and now we don't even need to free the client because we don't need to allocate it, we don't need to assert anything. This is much better, much better. So this is just the client itself, right? And we don't need any of that. So much simple, right? Yeah, I can even like call it network to signalize the name of this thread. I can say like network, and this is the state of the network thread. Why not? Why not? So I can just say that. Okay. So now I'm going to need a function called network launch, and this is going to launch the network thread, right? I know that libuv as uv thread. Yeah. So what is thread create? Yeah, probably need that. Probably need that. What is the extended version? Oh, it accepts parameters. I don't need any of that for now. Yeah. So I'm probably going to have a thread T, and this is a thread ID, right? So this is my thread ID. Do I need to initialize my thread ID? So thread init is there? No, I don't think I need. So I can just do create, and this is going to accept my network dot thread ID. Then I need the callback. So this is network. And the callback, what's the signature of this callback? This is the entry point. Once again, super, okay, it's right here. I was not able to see it. Okay, so I can just call it entry or like run or something. And this is the argument. So I don't need any arguments because I use a global state, right? So I can just avoid it. Like network run something. Yeah, just run because this is private. So yeah, I can pass run, and the argument I can just pass no because I'm not going to use it. Okay, so here I can basically run the event loop. I don't think I need to do anything else, right? Just do that, and here is network loop, and this is just going to run the default loop, and I think that's it. I still don't know if I probably don't need this here, to be honest. I can just have it here, I would say. Maybe. Well, let's keep it like that and see. Okay, but I think now this is going to work, right? So what do I need for this to work? So app is exposed and network exposes this stuff, right? Exposes that. So inside my CMD for the client, I need to include, so this is probably going to be called main. So it's the main thread. I'm going to have a main thread and a network thread, or something like, yeah, I still need to think in the name, a good name for it. But now I can include the network thingy, like so. And here, I can just do, before all of that, I can do network init, right? Network init. Then down here, I can do network close, right? right? But then I also need to wait for the that to finish. So here I can say UV thread join, and this is going to wait, right? I think it does wait. So I can just say network dot thread ID. It's very strange that I don't need to initialize that. Does this automatically initialize it? Probably because it accepts it by pointer, so yeah. But this also accepts this by pointer. I don't know. I really don't know. Let's test it then. Okay, so this is very complex, as you can imagine, for a single episode. But now let's try to test it. So we initialize it, and then we can just launch it. We initialize that, and we launch the network thread, and then we do everything else. But well, this is probably going to crash because there is a chance that. Oh, but that's independent, right? Yeah, for now, because we're still not loading any map or something, so it doesn't matter. Okay, so the server is running. Let's then try to do that and see how much we fail. Client is connected. Whoa. So it did connect. Did the server? The server didn't print anything. So creating a new client. Client. Client connected somehow without really. Oh, we don't have. We just crashed. Right, so probably. Why did we crash? Because yeah, we probably don't render anything. So let me do this for now and that. So we are not going to draw anything, just to check if that's the cause. Yeah, so the server is not really printing anything when the client. It should print, right? It should print connection accepted, but it didn't. Um, it must be somewhere, right? It's probably in the server. But yeah, I think I'm going to check that offline. I'm already been recording for 1 hour and 26 minutes. So I'll just check that offline. And yeah, so if the solution is simple, I just do that offline and then I show you in the next video what was the bug. So thank you for watching and I see you in the next one. Alright everyone, so I have a very quick update for you. So I basically terminated the episode and then I went for a bike ride. I came back and I found the issue. So basically, let me show you first what was the issue. So here on the server code, I don't know if you remember, but I basically had an init and a run function, and that basically screwed up the scopes of these variables, right? So these things either need to be global or everything, the run and initialization needs to be on the same scope, right? So that was the problem. That was the problem. So yeah, I think I can just have this app run for now, and then we figure out what we want to do. And then just for the sake of it, just to be completely safe, I removed also init from here, even though that was not the issue. And I just put both the init and the run on the same function, right? So now this should work. So let's first launch the server. And the server is going to take a little bit to compile because I'm recording. I basically I changed the encoder from GPU to CPU because it was a bit laggy, the game, when I used the GPU encoder. But now the compilation is taking a very long time, right? Because OBS is using CPU to encode the video, so I don't even know what to do. Okay, so here, as you could see, uh, we have an info log saying connected to server. I removed the rest of the logs because they are not really needed. And here we have the first initial logs, and then we have this accepting client connection and client connection accepted, right? So that's basically working, and that was the issue, right? So we should no longer have any problems with anything. Yeah, I still need to fix that because now I need to read from the server and I need to send data from the server to the client. But yeah, that's basically working now, and that is basically also working now. So yeah, that was the issue. So be careful with scopes when using Libuv. If you don't want to use heap memory, you need to be very careful with that. Otherwise, you're going to make the same mistake I did. But let me just remove that because I no longer need this, right? I no longer need this. And I think that's enough. Okay, that's the actual end of the episode. So thank you for watching, and I see you in the next one.